A constant volume of pizza dough is formed into a cylinder with a relatively small height and large radius. The dough is spun and tossed in the air in such a way that the height of the dough decreases as the radius increases, but it retains its cylindrical shape. That's cool. So that means we're tossing this pizza in the air and it's staying a cylinder. At times t equals k, the height of the dough is 1/3 inch, the radius is 12 inches, and the radius of the dough is increasing at a rate of 2 inches per minute. At time t equals k, what rate is the area of the circular surface of the dough increasing with respect to time? As a reminder, the area formula is given here, and we have to show our computations. Well, let's do some known toolbox, right? Let's create our known toolbox of things that we know. Okay, knowns. What are some of the values that we know? Well, I see here that the height is 1/3 inch. So height equals 1/3. The radius is 12, so r equals 12. And the radius of the dough is increasing at 2 inches per minute. So dr dt, the rate of the dough increasing with respect to time, is 2 inches per minute. All right. And now this question is asking us at what rate is the area of the dough increasing. So that means this question is trying to ask us to find dA dt. What rate is it increasing with respect to time? So we have to use this formula over here. A equals pi r squared. So we have this formula, and so what we have to do, because we are trying to figure out a related rate, how these rates are related, we have to find the derivatives of both sides with respect to time. If I do that on the left, the a, that's just going to give me, and I'll use a different color here so we can see this step. This will give me dA dt, because it's this derivative of a variable by itself. And this will equal, and I'm going to take out the pi, right, because pi is just a constant, times the derivative of r squared. R squared, we're going to follow the power rule, will give us 2r, and then by the chain rule, we have to then find the derivative of that variable with respect to time, dr dt. And so then I'm going to simplify this a little bit. dA dt equals 2 pi r dr dt. And so now we have this, but we need to figure out what's the actual value of dA dt. Right now we just have variables. So we go into our known toolbox, and I have r equals 12 and dr dt equals 2. So I'm going to use a different color, and actually let me highlight that in a different color too. So now we can see dA dt equals 2 pi times 12 times 2, which will equal 12 times 2, which is 24, 24 times 2, be 48 pi is dA dt. And this is 48 pi, and the units, because this is area, are inches squared per minute. And so we see here, where did I get minute? I know that it's minutes because all my rates are in terms of minutes. I know that it's inches because the original, the radius was increasing at 2 inches per minute. So this one's going to be 48 pi inches squared per minute. That is the rate at which the area of the circle, your surface of the dough, is increasing.